Good day, everyone. Welcome back to my YouTube channel, Learn Mathematics with Adi. Alright, so we are still on limits, and this is another question on limits. So I want us to listen attentively as I solve this for us. Say link 1 plus 2 plus 3 plus 4 plus plus n over root 9n raised to power 4 plus 1. Right, so as our n tends to infinity. All right, so to solve this, the first thing that we need to do is we try and simplify the one on top, the numerator, which is 1 plus 2 plus 3 plus 4 plus till n. All right, till n. All right, if you remember very well, under your series and sequence, arithmetic progression and geometric progression, this is an arithmetic progression or a linear sequence. So and sum is always given to the n over 2 into a plus n, n over 2 into a plus l, and I believe we know what our n stands for. N stands for the number of terms, and our l stands for the last term. A means the first term, so no need of stressing ourselves here. Can actually say sum to n here equals n over 2 into our a. Our a here is the first term, and if you look at that sequence, our a is 1 plus, and our last term here is also n. The number of terms is also n, since we don't know the actual number of terms there, so we take it as n. Right, so from here now we can say our sum, once we add everything here together, we add it as n over 2 into n plus 1. We say 1 plus n, which is actually the same thing. All right, so moving on now, meaning the question would have turned to n tends to infinity into n over 2 into n plus 1. I mean the one on top, 1 plus 2 plus 3 plus 4 plus a. The summation of everything gives n over 2 into n plus 1, right? So over square root of 9n raised to power 4 plus 1 plus 1. All right, so looking at this now, I can actually write this as n tends to infinity into, this is n squared over 2 plus n over 2, right? So over square root of 9n raised to power 4 plus 1. Alright, so the next thing to do is we try and divide both the numerator and denominator, since we have the tending to infinity. So we divide the numerator and denominator by the highest power of n. And the highest power of n here is 2, actually, because dealing with square root of 9, this, I can take square root of this, right, which is actually n raised to power 2. So our highest power here is still n raised to power 2. So we divide up and down with n raised to power 2. So meaning I can say I write this as then n tends to infinity into, don't forget we are using n over 2. So that n squared over, sorry, we are using n squared rather. To divide up and down we are using n squared. So plus n over 2 over n squared. So our denominator also is square root of 9n raised to power 4 plus 1, everything over n squared as well. Alright, so simplifying this further now, I can write this as n tends to infinity into n squared over 2n squared, right, plus n over 2n squared, right, over square root of this plus 1, then over n squared. Okay, so this is what we have now. So we try to simplify this further. try to simplify this further. So trying to simplify this, we can have ln n tends to infinity into n squared over 2n squared plus n over 2n squared over, don't forget that our n squared actually can also be written as square root of n raised to power 4. Yes, it will also give us our n squared. So meaning I can write this as square root of 9n raised to power 4 plus 1 over square root of n raised to power 4, right? Okay, so from there we have ln n tends to infinity into okay, just can cut this. Maybe I should just start with that. 1 over 2 plus this will be 1 over 2n rather. I've inserted my infinity, don't mind me. So over n, then over this can also be written as square root of, since they have roots in common, plus 1 over n raised to power 4, right? So from there we have ln n tends to infinity into 1 over 2 plus 1 over 2n over, we can break this one down to, we can split it like this, then plus 1 over n raised to power 4. Good. Alright, so from there we have ln n tends to infinity into 1 over 2 plus 1 over 2n over square root of, this can cut this, we have 9 now, plus 1 over n raised to power 4. Alright, so from here we can try to substitute now. We can say 1 over 2, right? Plus 1 over 2 into infinity. You should know that that would be infinity. Then root 9 plus 1 over n raised to power 4, which is infinity raised to power 4. Okay, so we have half plus, you should know everything here will be 0 over square root of 9 plus this one also will be 0, right? 1 over infinity, or 1 over infinity raised to power 4 will also be 0. So we have 1 over 2 plus 0, right? 1 over 2 plus 0 over square root of 9 plus 0, which is 1 over 2 over square root of 9 gives 3, right? Square root of 9 gives 3, which is actually 1 over 2 times 3 now, and that will be 1 over 6. 1 over 6. Thank you. God bless you. See you in my next class. Bye.